live from downtown Novi. Okay, notebooks out. Phone should be in the thing. There's only one there. I know there's far more than one person in the class. Also, as a heads up, we will be doing the BC Shakeout, which means at the end of this block, we will be doing an earthquake drill before you go. We will also be in the lab. That will be interesting. Okay, last day we're doing energies and reactions. Everybody can turn to this page. Put away your lab book, if that's what you have out. Get out these things. And let's quickly do it. Hello, how are you doing?
I'm doing washroom, or bedroom here.
Oh, clever. It's Jonathan, huh? How are you doing? I'm late again.
That's just only bad. It's not that bad. How many do you know? Let's get. Have you seen R9? You know the game R9?
I don't know how many.
I know it.
There we go.
Have you seen it?
Good luck, B.
What happened?
Please get out your materials. I should go to attendance. I've been reminded. Alexander. There. Maria. There.
No.
Ariel.
I just stabbed it. There's
There. Charlie.
No, I'm kidding.
There.
Got a mullet.
Alex.
Look at Alex.
Zhao. Here. Eric.
I never
Actually, one of them's out. He is away. Isaac.
Yeah. You know what a triangle is?
And
Triangle is delta. Basically, you
Isabel.
change it. So change it down.
And
And it is
Jessica.
something.
Katie is not here. Kiona.
Yeah.
There. Natsuho.
Yeah.
Sihu. Sterling.
Yeah.
And Jaden.
Yeah.
Tom. Is absent. And Tyler.
Yeah.
There's a lot of people absent. Okay. Last day we did energy in reactions, and we did a screaming gummy bear demonstration in which it cried out for mercy as we burned it up extremely rapidly. Demonstrate the principle of activation energy. It always requires some energy to start a reaction. That energy could be present in the environment. One second. If it's hot enough, or hot enough for that particular reaction, those are reactions that go spontaneously at room temperature, or it may require a match, or some heat, or a little something to get it started. Yes, sure. Were you here last day? Because we've been doing this one since.
Oh, but yes, I did that last.
Yeah, check what you have first before. And then looking at the diagram, this is a potential energy diagram. And now from last day, where's the energy located for a potential energy diagram? In the bonds. So the energy was in the bonds, and then the amount of energy in the bonds is gone. It has reduced. All that energy comes out into the environment. Alex, you have a question?
Oh, can the activation energy just be like kinetic energy? Like
That's all it ever.
active putting it in something?
The activation energy is the amount of energy it requires. It does take some kinetic energy to start, but it gets converted into potential energy. So that's more of a grade 12 topic. But for example, if you have two molecules, AA, so A2 plus B2 goes to 2AB, and their potential energy diagram is exothermic in the same way. The reason this goes up and it requires some energy is they have to hit each other with sufficient force to create the new bonds. So that's A2 and B2. When they hit each other in just the right way, they'll create that bond that adds some potential energy. If they don't hit each other hard enough, they won't create that bond. So it starts out as kinetic, turns into potential, and then when they drop off down the other side, they release the energy because they've broken these bonds. And then all that energy comes up. So it's the difference between the new bonds and the old bonds. Does that make sense? So, a really good point is that when you look at this diagram here, bonds forming, and on this side, bonds breaking. So first you form all the new bonds, and then you break all the old bonds. Now notice it doesn't say time on the bottom, and the reason it doesn't say time is because the reaction may not proceed. You might have two things hit each other, and they don't hit with sufficient force, or they're oriented in the wrong way, and the reaction just can't happen, and they bounce off. And then your diagram would look like this, a straight line where nothing much happens. This is reaction progress just means as the reaction proceeds, assuming the reaction is going to go, what is the energy in all the different parts? So it's like time, but not quite. Define two terms then. Exothermic gives off energy. And just as a little note then, you will always see its diagrams look something like this. And then endothermic gives up energy, and its diagrams look something like this. So this is energy out. And then it's energy in. Now, is there anybody who needed more time on the previous graph who was here last day? Didn't quite get very good. Got those two things. Then I don't think we did the endothermic graph. So I think I asked you to draw, you did, what an endothermic would look like. If you haven't yet, sketch in pencil, in case you need to correct it, what an endothermic line would look like. Yep, the next one, for an endothermic reaction, what would the line look like compared to the first one?
Oh.
Well, you're an extrovert.
Oh.
Excellent. Realization. So this one gave off energy because energy, the bonds now have less energy. In this one, the bonds gain energy. Do I have a dotted line in this one? No. So let's do something like this. Products have more or less energy in their bonds? More. This is then endothermic. The energy is absorbed from the environment. The activation energy, let's do that in blue, is from where it starts to where it has to get up to. It takes some energy to start, and you don't get it all back. So if you stop heating it or you stop doing it, that energy, the reaction will usually stop. There's another force in the universe that could make it go, but you're not allowed to know about that.
What is it?
You can't know it. It's the reason your room gets messy.
Reason about what gets messy?
Your room. No. I actually think the rooms would get messier without gravity. I'm always reminded of that podcast where one of the people said, you know, back when gravity was invented, and they were like, what, you mean like discovered? And they're like, no, like, why did we do that? It makes everything so much harder.
Oh.
Yeah, that's what everybody else said. Why does your room get messy? Why does time go forward?
Space.
Is a volume. But how do we know which direction time goes?
Do we?
We do read the clock. Everything winds down.
Are we assuming it's linear or no?
Oh, well, no, we're not assuming anything. I'm not going to explain time because that would be
2K balance.
let me get rid of this for a second, and I should probably turn. That's a secret force that you don't even know about yet. Yeah. Because all we know about right now is energy. And so one of the forces is energy. Entropy can be another one. If you put a lot of entropy on the other side, you can actually force reactions to go, even though they get colder. I could probably show you one of those in the future. In this reaction, where would we put the energy term? Like plus so many kilojoules? On the left or the right? Did it go in or did it come out?
On the right.
On the right. So we've got like plus whatever that is, let's say 100 kilojoules or plus energy. Because the energy is leaving the bonds. In this one, where would we put it?
On the left.
On the left. The energy is staying in here. Plus 100 kilojoules, let's say. Or plus energy. The amount of energy we have, let's pick a different color. Don't put that away. Energy gained in bonds. The delta H is equal to plus 100 kilojoules, let's say. That stands for heat, which is the energy change. And in this case, it went up. And so an endothermic reaction requires a constant source of energy in most cases. There are a few cases where it'll just suck the energy out of the room and it gets colder and colder and colder. Not that one.
So, electrolysis would be endothermic?
Electrolysis would be an endothermic process. Well, yes, electrolysis would be. There are electrochemical reactions that aren't electrolysis. If you just put something in, it'll just go spontaneously. And that's an exothermic version. But electrolysis, where you have to pump the electrons in and like coat something in metal, is a endothermic process because it requires energy. If you have copper, what kind of electrolysis were you thinking?
Like the one where you put turning the electricity in water.
Yeah, like there are, if you like copper coat a key or something like that, you have copper in the solution, you have copper on a bar to take the copper off, and then you're putting it on. Because copper is coming off and copper is going on, or you do silver, both ways, it actually is neither endo or exothermic. It's exactly zero, because it coming off takes the same energy as going on. You just need just enough energy to make the electrons move, because it's literally flat. One of few reactions that I can think of that where it would show that. We're eventually going to have a test. We're going to add in some naming though. But before we do that, balancing last day, which means I should have here some practice with reactions. Lab. Oh, there it is. These are just to draw your own versions of the diagrams, define some of the terms, make sure you're familiar with them. We are going to be going into the lab in maybe a bit before 8:55 and get about 40 minutes in there. Work with a partner. still. Nope. Demo disappear.
Yeah. I know.
What am I supposed to add?
No, I don't know, I just did it. Energy equals the that, right?
Okay, I just say energy released.
Ammonium thiocyanate. There we go.
What do you say for? I think he means like an actual example.
Yeah.
No, as in like not a form of shit, but like
I would say wood burning, huh?
yeah, exactly.
What is this? Copper.
It's gonna go like this. Dude, and then yeah. All right. Oh, now so did you do the lab yet? Huh? Did you do the lab yet? One quickly. Sure. Then we wait no one next. I think we're gonna do part one. Oh, today.
It's this, no, part two is the same as part one, except you choose how much of
Now, while you're continuing to work, if you have not yet already, pull out your computer and answer the ATL feedback form. How many of you have not done it or don't know what I'm talking about? Then pull it out and do that. It was emailed to you like several times. It's a Google form that says, are you occasionally, often, and why for things like focus in class?
No, yesterday, no, I haven't done.
This is your chance to tell me all the different things that you believe that you do. I am to evaluate you today in terms of your things like focus in class. Do you attend things on time? So I was to open one up. How many of you have not completed this? There you go. Go do that in there right now, please. You are, if you're new to Brentwood, I need to give you a reference to how well you're doing in class in terms of your learning skills, or as they now call it, approaches to learning, because they need to make it a little bit more confusing. Those are all the different things that that are. So I abbreviate time, focus, duty, and contributes positively. I just like, are you positive in class? In other words, do you work with other people and you have goodwill and good nature and want to learn? In addition to rating yourself in those, and then I would like you to give me some examples, because maybe, I don't know, you go to Mr. Snow for extra help every Thursday night, and I'm not aware of that, and that's something I should know. Or, on Wednesdays, you see Ms. Chung, and she helps you for 7 hours, gives up her sleep, and you do nothing but chemistry together, learning the class, and that's why you're so far ahead. Or anything else. Please fill it out right now. It shouldn't take you very long. It helps me see what you believe as well. In addition, what I'm looking for is, do we agree? Do you and I have the same idea? Because there's two problems. You never show up to class on time. Your homework is always late. You never mark your worksheet, so you have no idea what's going on. But you think you're a habitual. That would be weird. And that's a whole different conversation than just knowing that that's not what you're supposed to be doing. Also, this is not working. You show up on time, you do extra work, you help others, but you think that you're an occasionally. You are far too hard on yourself, and that is also a conversation. So either way, I like to compare mine to yours, and this gives you a chance to tell me what it is you're doing that I don't see. Because who knows what goes on in other houses during prep. As far as I know, in Whittle, it's just a party 24/7, nothing ever happens. No prep, no homework at any time. At least that's what someone was telling me. So, put it down.
I wish that was the same.
I don't really understand. Am I allowed to?
So basically, energy, the accuracy of the data is converted into time. Yes. It goes to the part of the game high. You name high, they collide with each other, and that's when the bonds are built. It's better than without a bond. The particles are just kind of moving along with each other, but there's not enough energy for you to hit and break whatever type of reaction.
You have 2 minutes
Like,
left.
I kind of understand. When did he talk about this?
No, yeah,
Were you here about the
it's kind of like, it gives the particles the extra. Hell no.
Oh, you have not yet retrieved it.
Like, think about it.
Okay, I'll have to go and investigate.
Under this activation energy,
Perfect.
the particles are just existing, right?
I didn't
Other
double check
releases
that.
the extra heat, you kind of go over the line and then
Well,
collide that.
better immune system.
Nah, they're really doing AP stuff, bro.
No, I'm doing English. I'm gonna do English.
Never use it. Never use it.
I finished it last night.
I was talking to this friend in grade 10. Math had a hard time yesterday.
Oh, Math 10 is so cool.
But he wasn't with it.
Wait, what do I need against what? What?
What? I have this backhand and I'm pretty sure. That's what I said. That's what I said.
Okay, bro. Okay, bro. Okay, bro.
Are we done? Done, Marcy? Done?
Yeah, there's a long ass.
Done all of it? I mean, do you have time?
Change.
How do you get it to
Seeking improvements, asking questions,
I sent
working with a person next to
said
you,
when I make it a security question instead, they said.
never giving up.
Oh.
So I can work on it at night because I don't have my phone.
No.
Yeah, we're gonna go to the
So I
library
did,
soon.
fire and so I did a cooking egg.
Wait, do you
original text.
It is not physical change.
What's not a physical change?
Cooking an egg.
Cooking an egg is a chemical change. Have you heard that you shouldn't look in a microwave because you like get radiation damage and you know? No.
No, it is.
Microwave wavelengths are way too long to give you any damage to your
That's
DNA.
like some Facebook
However,
post I
if
saw.
any of them are escaping the screen, it can cook your eyes like an egg. The fluid inside your eyes are clear like the egg white of a yolk, and if it cooks them, it will turn them white, just like the egg white of a yolk. That's a chemical change, and it is irreversible. Do not stare into the microwave, just in case the safety screen's not working. You will not get cancer from it. You'll just get cooked. That's probably bad. Okay, we're going to see if this works for reals. Now, this is one I do sometimes without it, but it is a little stinky, so let's see if it helps.
Yeah, I agree.
Oh, you did?
Because like it needs to
Straight
be
up.
less.
Exactly. Okay. Takes in energy.
Oh,
Absorbs that stuff.
maybe
Sucks it
there.
all.
Oh,
It's got a little bit of see. Okay. Gather round. Stand up, move these desks a little back, come forward, take a look. This is an unusual reaction because it has two solids.
You're sharing that.
You can gather around on this side. I just want you to sit there. I'm going to mix these two solids together. It's ammonium thiocyanate and barium hydroxide octahydrate. It's a bit of a cheat to say two solids. Two solids almost never react. But barium hydroxide octahydrate contains water within its formula. And so that water is released, which helps dissolve them a little bit and then helps the reaction go. Hopefully it doesn't get too stinky. But are you what? Are you looking at the data table instead of the really cool reaction?
The AI like character caught my eye.
Ah, yeah.
Because you did Mr. Snow before.
Oh, that's Scully from the X-Files. And you've never seen Beaker? Oh my God, you are so lucky. You now need to go and watch all of the Muppet Show.
Can I see if can I cite that for prep?
No. I said you're lucky, not that you can do it from home. You're lucky because now you can do that in all of your free time. Yeah. So that was two solids together, released a lot of water, but the reason I like it is feel the bottom.
Oh, it's so wet.
I put water there deliberately so it gets nice. Sometimes it freezes to the table. It will stink too, that's why I got this. It's got a real strong ammonia smell because it's literally releasing ammonia. Yeah, just waft. Do not sniff the top of this. I just said don't sniff the top of this. Have you felt the bottom? Feel the bottom. It's so amazing. Have you felt the bottom? Excellent. A trick sometimes, if you leave it there long enough, it will actually freeze to the top of the thing and then you can't move it. So this is an example of an endothermic reaction that goes spontaneously. This is getting colder, just like a fire gets hotter, but it's being forced because of that other force I mentioned. It's giving off ammonia. Giving off a gas is quite random. A liquid is more random than a solid. So all of that being on the product side is sort of pulling this reaction against its will, sucking all of the heat from the environment and making it cold over time. This is not quite how a cold pack works, but very similar. They wouldn't use this one because it never broke open, you get ammonia smell. But they have things like that where if you mix them together, it gets cold spontaneously and then you get a cold pack that you can break open and use in emergency. And it just keeps, well, until it's done and the reaction's done, and when it's done sucking in all of the cold, like there's literal ice on the bottom now, and it will start getting warm again. We'll leave this going so that the ammonia can slowly move up. Okay, you return your seats. That's your example of an endothermic reaction.
Wowzers.
Other than cooking pancakes.
That was wowzers. Wowzers.
Wasn't that Wowzers?
It was wowzers. So intriguing.
wanting it to freeze to the desk. These new desks are so smooth. I can't get it.
Oh my god, this is the most Asian scientific calculator of all.
Yeah, I was waiting.
That's my GCSE standard.
I should have gotten a wooden block. Sometimes you get a wooden block and it'll freeze the block and you lift the block off. It's like, wow, magic. Okay, I'm gonna stop.